Hey guys, welcome back to the shop. All right, I have a new project that I'm starting on here, and I wanted to get the camera and capture some of this and share it with you. We have a brand new pair of the Toolex vices. These are manufactured by Tico Work Holding. The Toolex is their line of these CNC style of vices, double station, quad stations, and they have all kind of jaws and other features that go with this Toolex line of vices right here. And I want to get these guys set up in the VM and start getting them machined. And these are going to be used to help us with the production of our VM3018 drill indexes. Okay, so we'll talk more about that here in a second. Now, I showed previously a couple other double station vices that we invested in, and that's the TMX vices, not to be confused with the Toolex. But what I discovered when I got those previous vices was that they were actually a little bit too long, too big to fit in our TRM, the tool room mill. The length of the vise plus the guards kind of like stuck out, which caused more interference problems there. So I wasn't going to be able to run those in the TRM. Now, they're still here and they're still going to be used for other jobs. But I was able to get in touch with the guys at Tico and talk to them about these Toolex vices, because they informed me that they had the shorter versions of what I was looking for, and they thought that this would be a really great solution for what it was that I was trying to do. Set up and have two vices dedicated to some production work. So not only that, you know, being able to fit in the mill. Now, I'm probably going to be running these on the VM mill, the new mill, but these will still be, you know, I can use these over in the TRM. So let's talk a little bit about how these work. Again, these are made by Tico up in Union, Ohio, made in USA, absolutely gorgeous vices here. They are drilled through so that you can bolt these down to a subplate. That's something I'm interested in doing, but I'm not going to worry about that right now. We're just going to set them up. They've got the rail machine in there so you can clamp them down, and that's what we're going to do. You can get either, these are 4140 jaws. This is a jaw set. We got another set there. You can get them in aluminum, and they're reversible. So you can snap them on here. These are considered the snap lock type jaws, and they have other accessories that, you know, snap on here as well. But you can machine these jaws so that when they're in here in one configuration, you can take them off and flip them around 180 degrees and snap them back on there and have another setup for a different part or a different operation. And the center jaw just simply flips over 180 degrees. All right, so these vices are 16 inches long, which was perfect for the TRM. They're 6 inches wide, and these jaw sets are 8 inches wide. And I just didn't realize that this kind of stuff, you know, I'm learning about all this modern manufacturing stuff, and I wasn't aware of this until I talked to the guys at Tico and them telling me that we have a vise that will work on your mill, and they explained to me how all this stuff works. So this is going to be the way that I wanted to approach this. So we're going to have one vise that's going to be for op 1, and we're going to have another vise that's going to be for op 2. Now, the way that I was originally talking about doing this was having 4 pieces of material in here, and, you know, machine all 4 for op 1, and then reconfigure the jaws, and then go back in here and finish op 2. I think what I would like to end up doing now is you're going to have 2 pieces of stock over here. We're going to machine these guys for op 1, all right, and then whenever that's finished, we're going to be able to take these out, flip them over here upside down, and this is going to be op 2. And then once we get rolling that way, you're going to have 2 machined over here for op 1, 2 machined for op 2 that are finished, and then when you're ready to go, you have two completed parts, actually be sitting like that you take out of the mill. You take these and you flip them upside down, and then you just keep going. So every time we hit cycle start, or every time the cycle's finished, should I say, we have 2 parts that are completed, all right? So here's the jaw sets. I'm going to show you how these work. So the center jaw is just made so that you can flip it over. You have these bushings that are threaded in there that line it up. You also have another pin there. So the center jaw just simply bolts down. Got a couple of socket head bolts that you use to bolt that down with. All right, and then you have these jaws. I'm just going to take this one off to give me just a little bit of room to work with here. And you have this jaw set right here. And the way these work is that you just hook it on the front side, pull it back, and you snap it in place. Just push it down, just like that. Same thing on the back side. Take it, hook it in the front, and you push it down. It is ready to go. It's just that easy. Again, this one would be bolted down right here, and that's bolted down. Now this is all the way open, by the way. All right, so you see you got a lot of material, a lot of available space here to hold larger pieces of material. So you have all this available to be machined. And the way you get them off, they send you this tool right here. It's like a little pry bar tool. And you can reach right back here, pop that one right in the front, pop that one up, pull it off, flip it 180 degrees, stick it back on there, snap it back in place. All right, let's pretend that's op 2. And you take this one that was configured for op 1, you take it and you flip it over. And then, well, actually you got to go this way, I'm sorry, because there's a dowel pin. All right, and there's your op 2. So my original thinking was to, you know, have both jaw sets machined for op 1 and op 2, but I think just to kind of get going, I'm just going to focus on one vise will be machined, and it's going to be machined for the Talon grips for op 1, and then this one over here for op 2, we're going to machine this more of like a soft jaw, so it'll have a step machined in here, and it'll be designed so that our finished op 1 part can fit down in there like that and hold 2 of those and clamp them in. So that's my thinking on this anyway. So really excited about this and looking forward to getting it set up. I am still planning on using the TMX vices, but those will be used whenever we have some other production that we want to do. I think these are going to be kind of dedicated specifically for the drill indexes, and you know, and we'll improve that whenever we need to. If we need to go ahead and machine the other side of the jaws for a different part. And of course, you know, these are available, so we can get some more of these jaws from Tico. You can get them in aluminum if you want to, and just have these guys on the shelf for different parts that we're wanting to machine. So I'm going to start getting these guys set up over on the VM. We need to get them clamped down, get them trammed in, get our jaws mounted on there. And then I'm still working on the programming now that we need to do for the machining of the jaws. But wanted to go ahead and show this part of it anyway. And so we'll start getting these set up on the machine next. All right, we're ready to start getting our vices on the mill and get them set up. We got our beautiful Saunders fixture plate on here. By the way, I've already removed the 4th axis off of here. And these holes here are not plugged because I ran out of the plugs, so I need to get some more of those ordered and get those coming. But we'll get those filled up later. The blue indicate our 4th axis bolt pattern there. The vices are going to go here. I've already got some 1/2-inch dowels to just act as a fence that we can push it back, and that'll help square them up pretty darn close. We've got our 8 holes already unplugged where we're going to bolt it down. And so we're just going to kind of keep it clean. We're just going to have 2 vices on here set up and ready to go. I've made sure both the table and the bottom of the vices are clean and ready to go. I'm going to go ahead and coat it down with our SP350. All right, we've got some 1/8 thick aluminum shims. I'll show you what we're going to use those for. And then I've got a handful of these shop-made clamps like this that's going to work perfect for these guys right here. I'd like to make some more of these that actually fit a little bit better. These I used on the flex arm plate that I machined in the Flex CNC a while back, but they're going to work perfect for this too. You sit on there like so. So the rear legs are just a little bit short, and that's where the 1/8 shims are coming into play, but I wanted to shim them anyway. Get some more of these guys in here. Just got 4 going, 1 on each corner. Just like that right there. Anytime you can shim these clamps, any kind of strap clamp or toe clamp that's being pulled down on your machine table, I would always recommend put some kind of shim or something underneath it where it's not pushing directly down onto the machine table itself. That guy there. Just over here on this side. And I'm going to use socket head bolts with these heavy duty 1/2-inch washers. We're just going to get these guys snug down, and then we'll put the center jaw on and get both the vices trimmed in where they need to be. I'm just trying to make everything look kind of uniform and symmetrical. That's how my mind works anyway. I don't know about others, but I just like things to be, as my buddy Tom would say, square to the world. Everything has to be square to the world. And of course, we'll torque those down once we get it trimmed. I'm going to have to tighten these guys down a little bit so that I can tighten up those center bolts, torque these down, and then I'll loosen them up again. We're going to go on here with our Noga stand. We got our Starrett 708 test indicator on here. All right, and we'll bring that down. We'll use our hand pendant and jog this thing around. We got our pendant here. Got to get used to this thing. Let's slow that down. There we go. Now let's just do a quick jog left and right and see how close we are. So, you know, this should be machined nice and square. I've got it pushed against those pins. I don't know if I'm crooked or not, but let's just see how close we are. Oh, I didn't get it square at all. Basically 7 thousandths. 7 thousandths off. Let me see, while I'm there, I'm just going to see if I can tap it just a little bit. Yep. Got a little bit to go here. We'll get it. This is pretty easy. Came off of it. I don't think that's worth really messing with right there. I think it's good where it's at. Probably within 2 or 3 tenths. I'm just going to snug these guys down, and then we'll move on to the other vise. Looks like it's within a couple of tenths, maybe about 3. I think we're just going to move on over to the other vise and go ahead and get it trammed in now. So I'm just going to double check both of them before I do the final torque on these bolts right here. That's looking mighty fine right where it's at, right there. Okay, I feel good about where they're trammed in at. We got both of them within 2 or 3 tenths across this jaw. Keep in mind, this is just a milled finish. It's not ground or anything. It's not super smooth, but that should be good enough to go right there. Got all the bolts torqued down. So I think we're ready to put our jaws on. We're just about ready, just about set up now. Okay, I've been getting all of my tool holders and tools lined up that we're going to use for this program, milling both of the Toolex vices. So we got one vise that's going to be machined for the Mighty Bite Talon grips. It's a 1/2 inch wide slot that's milled across on both jaws, and you have 1032 holes that are drilled and tapped all the way down. All right, and then the second vise is going to be machined as like a soft jaw would. So it's just going to be machined out, basically pocketed out. And I got the cutters that I think we're going to use here. So we're going to have a total of 5 tools. And these first 3 are going to be shrink fit. These are all our Technics tools. This one has a number 21 tap drill size in there, just a high-speed steel jobber drill that we'll use for our drilling. And then we have a 1032 spiral fluted tap in our micro float holder here. Hopefully that's going to work really well. I have never power tapped. I don't think I've power tapped smaller than a 1/4 20 before, so this makes me nervous, but it's supposed to work, right? So our first shrink fit is a 1/4 inch. This is a 3/8, and this is a 1/2. Our 1/4 inch tool here, we're going to use this YG mill drill tool. You can use this to spot. You can use it to chamfer. You can also side mill with it as well. So we're going to use this to spot all of our holes for our drilling and tapping, and then we'll also use this same tool to do the chamfering of all the edges there. So we'll shrink that into that 1/4 inch tool holder there. And then to mill those channels that I was just talking about, those are 1/2 inch wide, kind of like a keyway. We're going to use, we got a couple of new Walter carbide end mills here. We have a 3/8 4 flute. I've never used this one yet. So we'll shrink that in there, and that'll do the machining of the 1/2 inch wide slots for the Mighty Bite Talon grips. And then we have this 1/2 inch 4 flute that we're going to use to machine the Op 2 version of the vice jaws there. So it's just going to be just some straight milling, but we'll probably use like an adaptive program to get this milled. And I just decided let's just go with a 1/2 inch. So we'll shrink that in there. And you know, this is just a, you know, it's a 4 flute, solid carbide end mill. It's more of like a general purpose. So this is good for all sorts of jobs, you know. And I just dropped this down here. So anyway, we're going to go over to the Technic shrink station and get these 3 tools installed. Start with our 1/4 inch. Nice and cold. Change this to 3/8. I didn't get it in there all the way. Nice and cold. All right. 1/2 inch. Okay, we've got our tools installed in the holders, and now we are ready to get them loaded up in the VM. So we haven't really gone over the machine very much yet besides getting it installed. So we'll go over a couple of the updated features of the VM compared to our TRM over there. And one of the big features is having the side mount tool changer right here. We can hold a total of 24 tools in that carousel plus 1 in the spindle there. So 25 tools total, which is a nice benefit. We have 2 inches more in our Y travel versus our 3018 TRM. Physically, it's slightly larger. It feels like you have just a little bit more real estate space inside here. And one of the things that I still need to work on is some extra lighting. I'm just using my little cheapo clip lights, which has worked for 3 years over in the TRM. So I'm gonna get some more of these guys, but I wanna do some research and see what other kind of options are out there in the industrial world to maybe get some, I don't know, some magnetic lights that we can stick up in here somewhere and get some more lighting. I feel like when you're using these machines for your everyday work and you're not trying to get any video whatsoever, you're just using them for work, these built-in LED lights, they work fine, they get the job done. But when you're trying to really show detail on video, like I always try to do, you really have to update your lighting and add some additional lighting into the machines. It's made a big difference over the years, so we're gonna work on that too. But for now, we just robbed the clip light out of the TRM. All right, in addition to our 24 tool carousel here, our side mount, we have the swing arm tool change, which is a big upgrade from the TRM. So we get to finally see the quick tool change actions there. We do have a Renishaw. We've got it mounted here on the left side of the machine this time. That's just where it needs to be because of the tool setter and things like that. So We got our Renishaw and we are ready to start loading up some tools. So I got our 5 tools. We'll have to get them touched off on the tool setter, and hopefully this is all going to go really well. A couple of the other things that I have to keep in mind with using the VM is the safety features built into it. So doing things like tool changes and even jogging the table, I have to have the doors closed. So that's kind of, I got to get used to that and kind of work around those safety features while I'm trying to get some videos. So some of this stuff will be, have to be mounted inside here like this on the table. All right, well, let's get rolling on this. I do have a couple of tools already in the machine. We've got an end mill here. We've got an insert drill. We got a couple face mills. That was some stuff that Steve and I put in the machine to do a little bit of demo and work whenever he was here. So we're just going to leave those in there. I'm going to start with tool number 5 for our tool installs. We're going to go 5, 6, 7, 8, and 9. So I've got T5M6 in the MDI. And again, I got to shut the doors here. So we'll go ahead and put this tool away, and it'll be an open pocket for us to install tool number 5. Okay, just watching the screen here. Okay, so we did not get the manual tool install. So now we can go ahead and put our tool number 5 in here, which is going to be our 3/8 end mill. So this guy right here, 4 flute 3/8 Walter end mill. And now since we got that in there, let's just go ahead and get it touched off on the tool setter. All right, hand wheel mode. Bringing it down gently. Okay, all right, that one is successfully done. Now we can go ahead and get our next tool in there, tool number 6. I'm going to call up tool 6, so it'll put this one away now. Tool number 6 is going to be our spot drill chamfer tool. Put this guy away and call up tool number 7. That's going to be our number 21 drill. We'll go ahead and get it touched off next. All right, next up is going to be our tap and our micro float. We're on to our last tool, which would be tool number 9, so we'll go ahead and get it called out now and put this guy away. Alright, here's our tool number 9, 1/2 inch 4 flute end mill. All right, so far so good. We got all of our tools installed and touched off. I'm going to go ahead and call the probe out, and we're going to go ahead and, I think I already centered this guy previously, but I'm going to go ahead and recenter this vise, the fixed jaw here. Same thing on this vise over here. We're just going to make our work coordinate be the center of both of these jaws, and we'll make sure that's where it's set on our CAD program there as well. So on this machine, since we've got so many tool pockets, we can actually store the probe into our carousel there, which we have. It's actually in pocket number 16 there, the Renishaw. So as long as we have some extra pockets there, we can just safely keep it stored in the machine. And anytime we call up our probe, it'll bring it down and it'll turn it on. So that's a nice new feature that I get to enjoy here on this machine. So we'll work on that next, making sure our work offsets are probed properly. Okay, we called up our probe. I'm going to go ahead and get both these centered. So we'll use web in our probe cycle for both Y and X, and then Z0 off the top of that. All right, we are good. We are good to go. So what I'll do is I'm just going to jog it down there to the next vise, and we'll do the same thing. We'll go ahead and get that, and that's going to be our G55 work offset. That's setting our Z. Switch this over to web. All right, one more time in web. Change this over to our Y-axis. All right, that's both of our vices probed in there. I'm gonna just go ahead and gently bring our, yeah, see, I was going the wrong way there. Bring the probe up gently, get it out of the way. And then what I want to do, I got to figure out the best way to do this. I just want to get the probe put away so that it'll turn itself off. The machine turns it on. You can see the LEDs blinking there. I'm just going to call up tool number 1 in our MDI so it'll put this probe away. All right, making good progress. So we got all of our tools now put away. We got both of our vices trimmed and our G54 and G55 work offsets located and ready to go. So I need to go and finish some more of the CAD, the CAD and CAM on Fusion, get our tool path figured out. But the way we're gonna set these vices up is that we're gonna use a 3/8 shim on both sides there. Just make a 3/8 wide gap in there. And then we'll snap our jaws on, tighten them up, and they'll be ready to start machining. So really excited, and I'm also very nervous, but really excited actually though to see how the VM is going to react. Since I'm so used to the TRM, which has been a really great machine, I think this one's just going to be even better once we get rolling with it. Okay, slight change of plans going forward. What I would like to do is test the program on a piece of stock, not the vise, before I actually cut this. These are expensive jaws here. I don't want to mess them up. It'll be the first time really operating this mill here. So I'm going to remove this vise. We're going to put a standard 6-inch milling vise on there with the Talon grips. And I got a piece of stock that's basically the same size as this, but it was a little rusty. So we're going to clean it off, clamp it in here, and I've modified the program so that it just has one slot across there that's going to be milled. So we'll mill the slot, drill and tap the holes, chamfer it, all that stuff, but on a test piece over here. I'm going to get that set up, ready to go, and then I'll bring you guys back when we're ready to run some testing on it. We've got our mill vise and our stock set up. We're going to do our test cutting over here just to prove everything. It is mild steel, so hopefully everything will be okay. We're going to find out. We're going to go ahead and get our jaws snapped into place. All right, and what I want to do is we're gonna clamp these with 3/8 spacers. These are those magnetic Fireball tool magnetic blocks, but they don't stick very good vertically. They just kind of wanted to slide down. So just to hold them in place till we get it clamped, we're going to set the parallel right here. All right, and then we'll tighten up our vise here. So this is how we got it modeled on Fusion, is that it thinks there's a 3/8 gap between these jaws here. All right, that's good and tight. And we'll slide our parallels out. And we should be good to go. We're not going down in here. You know, we've got our 4 grooves that'll be milled. So, all right, we're gonna move over to our sample piece and we're gonna make some chips. I think we're ready to cut this test piece. I've made a couple air cuts across there, got some adjustments done, got our coolant adjusted, and I think we're just ready to go. I will definitely try to improve the video quality as we get moving using this machine, but for now I just got you set right outside the door. I've got to pay attention to this and make sure all of our clearances are right, so I'm going to be kind of paying attention more to the controller here. And wish me luck. We've got rapid and feed down on this. The Inspire controller, you have a rapid button and a feed button. So anyway, here, let's go. That's 5% rapid there, and I've got my feed kicked down as well. I adjusted the extent to make the cutter go off the block a little bit further, and I'm hoping that it doesn't plunge into it. It's looking pretty good. Looking at my screen here. All right, that's 100%. Doing a full slot there. We'll go down each side of the slot one time. Next up is our chamfer tool. All these tools I'm going to run down and make sure that we're not going to crash. That's not looking right. Either that or I just can't hear it. It's a 10 thou chamfer brake, but I can't tell. I'm going to bring it up to 100 on our feed. Doesn't seem like it's cutting. Yeah, I think we got a mistake happening. We're just going to continue through this, so it'll be a spot drill and then a drill, and then a tap. We'll see if we get those right. That looks pretty good. We're going to go with our coolant now. We got our drill bit. It's looking like it's drilling. Looks like it's handling it well. All right, let that drill do its thing, and we'll come back whenever we're done drilling all them holes. That'll take a couple minutes to get down that block. I need to modify my tip brake, reduce the distance for the tip brake. I got a bird's nest on the drill there now. It was doing pretty good against flinging coolant all over the window, but now those chips are getting it everywhere. One more hole to drill. And then it'll grab that mill drill, and it's going to chamfer the hole after this. Let's run this down nice and slow. Let's get our first one. Okay, I think that's good. If you'll notice that middle coolant to the right of the cutter, that's positioned that way for the tap, because the tap sticks down so much further than the rest of these tools. I wanted to ensure that the tap was getting some coolant on it. This is going to be the next guy coming up here. All right, here goes nothing. Man, it makes me nervous. 1032 tap, spiral fluted tap. We're running that in that micro float holder from Technics. Got a little bit of axial play in there. Seems like it's doing well. I'm seeing that chip come up out of there like a drill bit. Last hole. There it is. Okay. Exit out of that. All right, let's take a look. See what she's looking like. Everything looks good, but I think we cut our slot too wide. But real happy with the tapping there. That's what I was really most nervous about. Let me do some inspection here and see what's going on. I definitely made some mistakes on this, and this is why I'm glad that I used the test piece instead of jumping right over here to our 4140 jaws. So as suspected, the slot is wider. And what I have learned I remember in Fusion, I set compensation type for this cutter to be wear. And when I do that on the machine here, I have to set the diameter of the cutter at 0. I forgot to do that. It's still set at 3/8 diameter. And it makes sense because I measured the slot being 5/8. It's actually a few thousandths under that, but nominal size would be 5/8. So half the diameter of the cutter per side makes it 5/8 when we use that end mill there. So I can make an adjustment on that. That's easy. But the next problem I have is whenever I went to test the screw, it instantly was tight going in there. Now it's trying to go in there, and you can actually force it in there, but it's tight. So I'm like, okay, does that mean that that's drilled and tapped the wrong size? And in fact, it is. I went ahead and rechecked the screw, and apparently the screw size is M5 by 0.8, the pitch, which is almost identical to a 1032. I mean, they are so close. You can see this one, you could screw it in there, but it noticeably gets tighter as you go in there. So it's so close that even with the screw pitch gauge, I thought I was reading 32 threads per inch. So I measured it and checked it again with the metric screw pitch gauge, and it seems like it's dead on M5. All right, so I took this hand tap, which is an M5, and I ran it down in that one hole, and the screw now screws in there like it should. So it's got to be an M5 screw. That took me off guard because I thought for sure we were measuring a 1032. All right, so the slot width I can fix in our on the tool diameter in my tool table. The tap is another story though, because all I have is hand taps and I have a gun tap, which really isn't what you're supposed to use with a blind hole because chip packing. Now we could use it and make sure that it's going to work, and I may just do that, but I need to order this tap, which is probably going to take at least a couple of days to get here. So I need to do that. I need to order some taps, and then we'll revisit this. So I'm going to go ahead and I may go ahead and get this chucked up in our holder and just shallow up the depth there and tap it anyway, just make sure the screw's going to go. But I'd rather use a spiral flute to do that. So I got a little bit of work to do, and this is a little bit of a setback on my plan here, but what can you do but just keep moving forward, correct the mistakes, and hopefully get it right the second time. So I'm going to get some cutters, some taps on order. I tell you what, it did a beautiful job, that end mill did. I mean, it is just silky smooth down in there. We just cut it the wrong size is all. So I got a little bit of modifications I got to make to our program here, but I want to get this right before we move over here to our 4140 jaws.